discuss with you the code forces problem D of code forces around 718. This is the problem statement. I will briefly explain you what it says. So basically, it says that we have n into m points, n horizontally and m vertically, or you can say n vertically and m horizontally. So what we have to do is, if we start from this point, then we can go either to this, either to this, either to this, or either to this. We have possible four options. So we need to travel exactly k edges, and after traveling exactly k edges, we need if we start from here, then we need to end here. So we need to travel k edges and start from here and end at here, and we need to find the minimum distance which we can travel. So what is the minimum distance which we can travel by traveling exactly k edges? This is the question. So from here we can go to this, and this. So if we write a recursive code without thinking, so this code will look like this. That we I taken initially I take an input, and this is where the starting point. I and G are the starting point. This I have again given ing because this is the source, or we can say starting point, and this will change, and this is the value of k. So here we can see that in the recursive code, and this is the recursive definition which says that we can go we can go from here to four possible routes. So this is the recursive code, and this is the base condition in which we can easily recognize that if I equal if k we can say if k equals to 0, and this condition also true, then we need to return 0, else return infinity, because uh, not else. If this condition matches, then we need to return infinity, because this is the condition where fault can occur. So this is the basic recursive code. If we want to optimize this code, we can do it by dynamic programming. But if you look carefully, then I have exactly n into m points, where n is 500, m is 500, limit n is less than equal to 500, m is less than equal to 500. So for all 500 into 500, 25000 points, I need to again uh, calculate, because these are the values which are different for all. I can't use a DP at that in that case. So in that case, my DP table will be like this: in the DP of I, J, K, S, I, S, G. This DP table will surely lead to KLE or MLE. We can say that. So this is not the optimal case. So what we can do now to optimize this? So if we think carefully, first observation we can make is, if we start from here and end at here, we can't make odd number of steps. We can't make odd number of steps, because for that there we need some edge like this for making odd number of steps. So we can't make, because there is no edge like this. All the edges are like this. So there is no possibility of making or number of there is no possibility of making key exactly uh, going from this and traversing k edges and returning back to this. So there is no possibility when k is odd. So this is the first observation we can make. If k is odd, then we can easily output answer as minus 1. But what if k is even? So let's suppose k is 4. So from here we can go to here, 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 and come back here. Or we can 1, 2, 3, 4. Also do this one. So basically, if we think, we can see that if this is A, let's suppose this is A, this is B, C, and D. So we can make 4A, 4D twice of A plus B, or twice of C plus D, or A plus B plus C plus D. So these are the 5 options. I can go from here in these and uh, choose one of these 4. These are the 5 possible options. So one thing if you notice is that this is not this case, and we need to analyze this case, because if we are going from A, B, C, D, what it means? It means that we can also come back. We can also come back from B, but why we are moving and D? If they are exactly, if they are equal to this, or we can say that they are the distance between this point and these points are same. So either we select A plus B or we select C plus D. So from both we can't select these both. Why? Because out of this A plus B is minimum or C plus D is minimum. If both are equal, then we can select any one of them, and it is sure that one of this is minimum. So if A is minimum, then A is lesser than B, so we can take 4A. So one thing here we can notice is we need to travel exactly k by 2 edges. So why? So we can do one thing, that is we can make our k equals to k by 2 and find the answer for k by 2 and double the answer. So the code for this is this, and in this what I have done is, this is the recursive code which I have written. This is simply the previous one. If k percent is not equals to 0, then c out minus 1 continue. Else uh, we can find the answer for ij and k by 2. So here is the code, and this is the recursive definition. This is the same code. There are slight changes in this. That is, we don't need a source vertex, that is I and j, because the quotient reduces to we need to only traverse k by 2 edges, and we don't need to go back to the edge. Why? Because if we traverse exactly k by 2 edges, then 1, 2, 3, 4. If we traverse 4, or we traverse 1 or 2, or we can say if we traverse a plus b, then we are surely traversing it double. Because if we go from here to here, then c plus d is c plus d is greater than a plus b. This is sure. So we will return back to this. So uh, for k by 2 we can find the answer, and the next k by 2 we are traveling the same. So that's why we are doubling.